Up to now, I've taught almost all the things in traditional programming problems, which means that x could be any number which satisfies certain constants. However, in certain applications, the value of x may not be allowed to choose arbitrary number, a real number. For instance, if you have to find what is the minimum number of people needed to solve a problem, so x here must be an integer. So this leads to another type of optimization problems. We call it integer programming problems. So it has to be 0 or greater than 0. Not necessarily. For a number of people, it must be larger than 0 or 0. But for certain problems, it could be a negative integer. So we have to introduce integer programming problems. And also, in the variable x, because it may contain several components in x, some of the components are required to be integer, and the others are not required to be integer. And this kind of problems are often referred to as mixed integer programming problems. And integer programming problem is a special case of it, so they call it. So we mix the integer programming problems. And also for a special case, if the variables x are required to be 0 or 1 only, we call it binary programming problems. So there are some concepts I have to give up, have presented first. So we have to talk about integer programming problems, mixed integers, and binary problems. And here we shall talk about the solutions of this kind of problems. And to solve these problems, to solve mixed integer programming problems, there isn't any existing Matlab toolbox. The optimization toolbox cannot deal with this kind of problems. We have to use a third-party program. For instance, the one developed by Dutch people using the branch and bound algorithm, which implemented a free toolbox. And this toolbox can be used to solve certain problems. And I've also uploaded this toolbox in the web page already. And I myself did some modification to the program. So we can use it to solve certain problems. So let me demonstrate how to use it. This is a function to use. And from the function, you may see that several of the arguments are quite familiar. For instance, the objective function here, the initial search point, the lower and upper bounds, the linear constraint and nonlinear constraint. These are familiar. They are exactly the same as those defined in other Matlab functions, for instance, as mean, CON. So these are exactly the same. And the only difference is here, is this. It is a vector which is of the same length of x, contains zeros and ones. It indicates which components of x are needed to be integer. If the number here is 0, which means that the corresponding x is not required to be integer. If the entity here is 1, then the corresponding x should be 1. That should be required to be integer. So we can use this command to solve the original problem. And it should be noted that the anonymous function defined in Matlab cannot be used in this function, because this one is developed very early, about 10 years ago. So the new facilities like this is not supported. return variable, the return formats are different from the F-mean functions or other functions. This is the expected x to be returned, and this is the objective function. And this one is supposed to be a string vector. If the string vector is empty, which means that the result is successively of n. If it is not a string vector, if it is not an empty vector, then the result might be suspicious. This one may contain. This one may return an error message. So now let's